You've probably already read it, but I got to read it here. 2 distinguishable fair dice are rolled, 1 red and 1 green. Let A represent the event that the red die is a 2 or a 4. Let B represent the event that the sum of the 2 dice is 6. Find the conditional probability of B given A and express your answer as a fraction in lowest terms. Okay. So sometimes it's good to write out the possibilities.
Mhm.
So if A is a 2, B could be a 1 through a 6. And if A is a 4, B could be a 1 through a 6.
Mhm.
Okay. And the conditional part means that we assume that the first part is true.
Yeah.
Assume that you rolled a 2 and a 4. So in terms of like your total outcomes here, there are 2 for A and 6 for B. So there's 12 on the bottom.
Mhm.
But the ones that we want, the sum of the dice being a 6, the only way that works is if you roll a 2 and then a 4, or a 4 and then a 2.
Yeah.
So there are 2 of those. And the number in the top is the one that makes this true, and 12 is the total possible. So that reduces to 1 over 6.
Oh, okay. Okay. Can we also look at number 21?
Yes. Sounds like you've done some of these already on your own. That's great. That's always
Yeah.
the best way to do it. All right, roulette wheel. Have you done any fun casino gambling yet?
Not much.
Not much. Okay. Yeah, sometimes you get these problems. You're like, I don't even know what a roulette wheel is.
Yeah.
But it's numbered 1 through 36. It alternates black and white, and there's green and double green, or green for 0 and double 0. And they're giving you some possibilities. So bet on 4 numbers, pays 8 to 1. They give you that. Okay, how much do you expect to win with a $1 bet on 4 numbers? Okay, so yeah, this one really does require you to sort of know how this works. So I don't remember exactly how it's laid out, but I'll just use the way this works is like 1, 2, 3, 4, and you can put a marker or a chip right in the corner there. And if you get any of those numbers, you win. So we need to look at win and lose scenarios. Okay. And we need the how much you win. So think of it as how much, and then the probability of the event.
Yeah.
Okay. So the let's look at the positive here. If you bet $1 and you win your dollar back plus another $8. So your net to you is 8.
Yeah.
Does that make sense?
Yeah.
And then there's 38 total places that the ball, I think it's a ball on the roulette wheel that it falls into, but there's 4 outcomes that we think are good. It doesn't have to be 1, 2, 3, 4. It could be you're just putting that marker in one position, but there's 4 possibilities that allow you to win out of 38.
Yeah. Okay.
But then the other one, which we don't like as much, but you lose your dollar. It's gone forever. Okay. And that happens, well, the other 34 out of 38 times.
Yeah.
So the key here is to recognize that the probabilities have to add up to 1.
Yeah.
No matter what the events are. Sometimes they give you like life insurance type problems. And now your expected value is the product of how much you would win or lose times the probability.
Yeah.
Plus, again, how much you expect to win or lose times the probability.
Okay.
And this requires a, well, I guess it could be done as a fraction. I mean, you can go right to calculator. It's 32 over 38 minus 34 over 38, which equals -2 over 38, which means on average, you're going to lose this bet.
Yeah.
And that's how the casinos make money. You're paying for entertainment there to watch yourself, win, lose, draw. But most of the games are biased in their favor. They have to be. So this is your answer. Now you could go to a calculator and get a number, and that would be in dollars, minus 0.056 cents. You're going to
Yeah,
lose, or dollars per time. Main thing here is the setup. Okay, do you feel like you could reproduce that?
yeah, yeah.
Fantastic.
That makes sense.
All right, what's next?
22.
22.
I know
Okay.
how to do the like mean, but I was just like struggling to do the
Are you allowed to use
second half.
Are you allowed to use your calculator for this?
No.
No calculator?
Or we can use it to find the number, but she wants like the work all written out.
Oh, okay.
Sorry.
All right. Yeah.
Yeah.
I was like, wow, that's it's brutal. Okay. Okay. So X bar, you're adding up all the numbers and you
Mhm.
divide by the number of numbers. And I'm sure you know how to do this, but I have to show it because we can't get the next value without doing this. And
Okay.
I just need to get something open to be able to do this. Give me just a moment here.
Yeah, I know the answer to that part. I know is 5.
Yeah. Oh, it is 5. That's good to know.
Yeah.
Okay. That actually will save me a ton of time here. All right. So for the standard deviation, I recommend making a table. The first column is your samples. So that's the 4.2, the 4.7, the 5.4, 5.8, and 4.9.
Okay.
The next column is the sample minus the mean. And you can either put the result or not. It's up to you. 4.2 minus 5 is minus 0.8. 4.7 minus 5 minus 0.3. 5.4 minus 5 is 0.4. 5.8 minus 5 is 0.8. 4.9 minus 5 is minus 0.1. The next thing is to square that result. You take that number you just found and you square it.
Okay.
Minus 0.8 squared is 0.64. Minus 0.3 squared is 0.09. Positive 0.4 squared is 0.16. 0.8 squared is 0.64. Minus 0.1 squared is 0.01. So what you can do is you can go right from first column to the last one if you want. Like you can see all you're doing is
Yeah.
squaring the result. Maybe after you've seen it one time with me, you'll say, oh, I got it now. Next thing is to add up all these numbers. And I get 1.54, but please double check.
Yeah, I got the same thing.
Okay. So the standard deviation is the square root of, in the numerator is the summation of xi minus x bar squared. What that means is the number you just found, that's why we added them all up, over
Yeah.
the number of numbers minus 1. So you have 5 samples.
Okay.
So if when you do this in your calculator, make sure you put either put 4 on the bottom or put it in parentheses first. But that will that should do it here for you.
Okay, thank you. That makes way more sense.
Yeah, of course. Does that work out though for the answer the way you want?
Yeah, yeah. Actually, I had the wrong equation.
Oh, do you get a reference sheet for this that I should grab formulas from to help?
No, I don't. I just
Okay.
have been taking notes of the
All right.
equations.
All right. You can only use the calculator method to check your answer. Oh, okay.
Yeah.
Brutal. All right.
Yeah.
Yeah.
I guess can we go on to just the next question then?
Yes. Yes. I could tell the distance between questions was getting smaller, so I figured we might be
Yeah.
going one by one now.
Yeah.
All right. Using question 22. Okay, the one we just found. What range does the empirical predict that approximately 90% of unemployment rates will fall? Let me give you the 68% and then the 99.7% as well, because those could all be on there. But we'll start with 95%. So
Okay.
95% means you're going to subtract one standard deviation, and then you're going to add one standard deviation. So your excuse me, your mean is 5, and then your
Mhm.
standard deviation, I didn't even get that. What was the result here?
Um,
I'll get it too if
it was a really long decimal.
so we'll go 0.62. Does that look reasonable?
Yeah.
Okay, so you have to take 5 plus 0.62 and 5 minus 0.62. So the adding is always easier. That's 5.62. And then this one is 4.38.
Yeah.
I'm sorry, and I'm really messing up today. Apologize, it's early. See, that's 68%. For 95%, you're going out 2 standard deviations. Okay, so the couple ways to do it, you can keep adding to the original one, another standard deviation, or you can take 2 standard deviations and multiply by, or over here on the left, you subtract 2 standard deviations.
Okay. How do
from
you
them.
know how many standard deviations to go out?
Good question. That is the empirical rule. The empirical rule tells you standard deviations, 68% is 1, 95 is 2, and 99.7 is 3.
Okay.
You're expected to know that for this
Okay.
part of the course. Meaning that like they're not going to give you that on the reference sheet or anything. You're going to have to
Yeah.
figure that out. So then the 99.7%, you start with the mean, but this time you go out 3 standard deviations, subtract 3 standard deviations. Like that.
Okay. Okay. That's
All right, give me just a moment here. All right, so the do you need any help calculating these, or is that okay?
no, that's good.
Got that. All right. So next question, part B is, sorry, going back. We're gonna go back to that data set.
Mhm.
All right, what is the actual percentage of employment rates fall in the range predicted in part A? So what they're saying is go to that one. So we do need this. We do need this middle one here. Let me, sorry. So we need this. We do need these middle values here, 5 plus 2 times 0.62. Do you have those, or if not, I'll calculate them here real quick.
Yeah, I can get them quick.
So 6.24, and you've got the other one.
Yeah. Sorry. 6.86.
No, the one going left.
Sure.
It's the one going
Oh,
left. So
shoot, sorry.
you're subtracting.
Yeah, sorry.
Stuff.
3.76.
Good. Okay. So what question B is asking you is how many of the original data points fall from 3.76 to 6.24?
Mhm.
Okay, so you're going back to that original data set. I'll snip that in,
Yeah.
and we're just looking. Basically, it's a yes or a no. And
Yeah.
it's looking pretty solid that most of them actually do fit in there. So check, 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 check.
Mhm.
So it's 100%.
Okay.
On an exam, they typically like leave one out so that you know you're not just saying all, but could
Yeah.
really depend. Really depend. All right, then part C. So there's this thing called Chebyshev's rule. Chebyshev's rule is different. It's it's 1 minus 1 over k squared, where k is the number of standard deviations.
Okay.
So the way it works is it says, like, if you're within one standard deviation, and we do this formula, I guess it's not valid for one. Let me just double check if they use it for one or not.
Okay.
Yeah, I guess they do. So we're not going to do it for one. That would be ridiculous. We'll do it for 2 standard deviations. And what it is, it's the percentage that fall in that range. So 1 minus 1 over 2 squared becomes 0.75 or 75%. And what they're saying is that within 2 standard deviations, when you use Chebyshev's, 75% of the data should fall within 2 standard deviations.
Yeah.
Within 3 standard deviations is 1 minus 1 over 3 squared, which is a lot better. It's 8 over 9, ends up being about 89%.
Yeah.
Okay. And so the question is, well, which gives a better prediction of part B? I guess it's Chebyshev's, because no, sorry. Within 2 standard deviations, we're comparing to the empirical rule. So the empirical rule says 95%, 99.7%. And you can see that all the data fell within there,
Yeah.
which means that the empirical was better than Chebyshev's. 95% is closer to 100 than 75.
Yeah.
They sometimes ask you a question on Chebyshev's, so you may want to remember the formula.
Yeah.
Remember that K is the number of standard deviations, but not much else. And here we go. Number 24 here. All right, using the probability distribution table in question 20, assuming probability of x equals -2 equals probability of x equals -1, calculate the standard deviation around 2 decimal places. Okay, so we're gonna go back to 20. Why can't they just give you the table? I mean, it's like, really cool. All right, new. All right, so I think, I'm guessing you got 0.2 and 0.2 when you did it this way.
Yeah.
Great. Okay, so to calculate the standard deviation, the hint here is to first calculate the mean, the expected value of x. So the expected value of x is the summation of x times p of x.
Yeah.
And what that means is you take each x value and multiply it times the p of x.
Yeah. Okay.
So minus 0.4.
It ends up being
Do you have the total
negative 0.3.
like that?
Yeah, so that was
Okay.
what number 20 was asking.
Great. So the standard deviation of x, you have to actually find what's called the variance of x first, and then take the square root. The variance of x is the expected value of x squared minus the expected value of x all squared. You already have the second value. That's the expected value of x squared. We need to calculate this value now. And it's very similar to what we just did. So we have to kind of come off to the side here and find the expected value of x squared, which means you're squaring the x values. -2 squared times 0.2 plus -1 squared times 0.2 plus 0 squared times 0.4 plus 1 squared times 0.1 plus 2 squared times 0.1. It's exactly the same as this line up here, except you're squaring the x values.
Yeah.
Do you have a value for that?
Yeah, I got 1.5.
1.5. Okay. So now we go back to the previous line here. The variance of X is 1.5 minus negative 0.3 squared. And then the standard deviation of X is the square root of that result.
Okay.
So you can get this number and then take the square root of it to get the standard deviation.
Okay, yeah. Do you want, I got 1.187.
All right. Yeah, just double check if that's different than the answers. Assume you have
Yeah.
those.
Yep, that's right.
Great. Now, a lot of formulas like I threw at you for this. You don't need to remember the formula, you just remember the execution of it,
Yeah.
the squaring of it. I mean, this isn't rocket science, right? This is just like, okay, got some numbers, got to multiply. You can do this. Just got to make sure you know the formulas.
Yeah.
All right, 25.
Could we move on to 27?
Yes, 27, you said?
Yeah.
Yes. Oh boy, your calculus is coming back.
Yeah.
All right. When you take brief calculus, that's the amount of time that you remember it for. That's a joke.
Yeah.
Sorry. All right. Determine the value of K so that f of X equals 5X is a probability density function on the interval from 0 to K. All right. What this is saying, and we'll go to the calculator if needed. So any probability density function, when you integrate it over its interval, has to equal 1. Okay, so this, like you saw this in your calculus course,
Yeah.
there were numbers here. Just try to ignore the fact that it's a K for a moment. Do you remember how to find the antiderivative of 5X? Okay, so it's real simple. I'll write it off to the side here. The constant's there, so that's okay. What you do is you add 1 to the exponent and you divide by the new exponent.
Okay.
So the 5 comes down, you add 1 to the exponent because it is 1, and then you divide by the new exponent.
Okay.
There's your calculus. So this is really 5 over 2 x squared, and then you are supposed to evaluate it from 0 to K.
Yeah.
So that's what this notation means here on the right. To me, the notation isn't all that important for what you're trying to do. What you have to remember is that it's top minus bottom. So you take that K and you put it into the function. Minus, you put 0 in to the function. And normally, normally the top is a number like 2, and you're done. Okay, but in this case, you're setting it all equal to 1.
Oh yeah. Okay.
So then this becomes 5 over 2 K squared equals 1. And you're solving for K now. So the next step here is to multiply by the reciprocal, 2 over 5. And then you're going to take a square root of both sides. There are really 2 solutions here, but because your problem said from 0 to K, we know that K must be greater than 0.
Yeah.
Okay, so this is the exact answer. You can rationalize, you can get a decimal, you can leave it. It's probably okay like that.
Yeah.
Okay. I'm sure you just despise seeing calculus, stuff again. Like, do you want any review on this? Anything to help you?
Um, can we just do like another problem like it? Like I think the one above it is similar.
Yes. Absolutely.
Okay, thank you.
I was helping a student a year or two ago, and I think the final was really similar. So she just relearned enough to do the problems and did okay. Like you don't have to
Yeah.
you don't have to relearn calculus on this.
Yeah. My teacher
Okay.
didn't really go over this, so I was just surprised seeing it on here.
Yeah. Yeah. Well, that's not helpful. Okay.
Yeah.
So the idea is that you're integrating the probability density function, and
Mhm.
and it should equal 1. Like that's what you want. You want it to equal 1 if it works out. Like you're like,
Yeah.
yes, it works. We'll see. So you integrate always from an A to a B, so a bottom to a top. And this time your function is X. Okay. And what you're hoping for, you're really hoping is that this equals 1. We'll see.
Yeah.
So the antiderivative here is you add 1 to the exponent. There's no constant this time, but you just add 1 to the exponent. And then you divide by the new exponent. So it's x squared divided by 2, and you have to evaluate it from the top minus the bottom.
Mhm.
So that's 2 squared divided by 2 minus 0 squared divided by 2. And you're hoping it equals 1. This is 4 over 2 minus 0. 2 minus 0 is 2. This does not equal 1. This is not a probability density function.
Okay, thank you.
Yeah. Do you want us to do 28?
No, I think
Okay. 28 is
that
like
makes
27
yeah.
in a lot of ways. It's not exactly the same, but
Yeah, just like fill in the blanks. So um,
where to next?
could we do? Sorry, I'm just reading what the next.
Yeah, take your time. Sorry for rushing you.
No, you're good. Could we do number 30?
Yes. Suppose a website is losing its membership continuously at a rate of 5% per year. Use a suitable density function to calculate the probability that a randomly chosen member will be lost in the next 4 years. Okay. 30 is what part of the course here? I'm guessing you guys are doing, did you guys do exponential distributions? Do you know?
Yeah.
Okay.
Yeah.
Okay. So let me just I always want to write this down correctly, but there's the United teachers like, don't go to Wikipedia. It's awful, right? Well, that's exactly where I go for these distributions to get the PDFs and CDFs, because it's actually really just fine. Bad stigma there. Okay, so the idea here is that you integrate from 0 to infinity, which is the last thing you want to see, but lambda e to the minus lambda x. Okay. And the question is, well, what is lambda? Lambda is the rate.
Yeah.
Now, if you've never seen this before, please tell me. I'll try my best to make this as easy as possible.
Yeah.
Your rate is 0.05. So if you were to integrate this function from 0 to infinity, 0.05 e to the minus 0.05 x dx, you would get 1. That's not what they're asking for, but that's like the setup.
Yeah.
Okay. And you're not getting any of this on your test?
No.
Oh, I mean, that you might as well be taking a IEEE 380 right now. This is the kind of stuff they're doing. Interesting. So why wouldn't they do that? All right, now the antiderivative of this is known. So the antiderivative is, and are you allowed to use your calculator though? Like if we put bounds on this, could you just use your calculator and give the answer? Would that be okay? Or do you think you have to show the actual antiderivatives and evaluating it?
I think we can use our calculator for this.
Okay, that's good. That's good news. So in the next 4 years is 4. Integral from 0 to 4, 0.05 e to the minus 0.05 x dx. Do you want me to show you how to do this in your calculator?
Yes, please.
Okay, give me a moment to get that up. All right. Do you have a 83 or 84 calculator?
Yeah, I have an 84.
84. So yours will be probably cleaner than mine in terms of the setup here. So it's under math.
Oh yeah.
9, math 9. Now, when I hit enter, I don't get the integral. I think you get an integral symbol.
Okay, I'll put it in and see. Oh yeah, I do. Sorry, I thought.
Yeah, you get a nice integral.
Yeah.
So you have to fill in, if you need me to, I can go back to the other screen, but you've got to fill in the bottom bound is 0, the top bound is 4, and then the 0.05 e to the minus 0.05 x.
Yeah.
I believe I have to do it this archaic way, minus 0.05 x comma x comma 0 comma 4. Okay. Let me know if you need me to go back to the other screen, but
how do you get the because it's still to the negative 0.05 times x power, right?
yes.
Oh no, x is 0.5 though.
No. X is not. You're. Let me go back to the screen because yours has the integral in it. You have, I think, like when I recall, they have like a box there, a box there, a box, and then D box.
Yeah.
So you're going to put an X there, 0 for 0.05 e to the minus 0.05 x.
Yes. Okay. Okay. Yeah. Now I understand. Okay. Yeah. Thank you.
Awesome. So let's keep going here.
Mhm.
Gotta go back and find where we were. There it is. All right. What's next?
31. Please.
31. Sure. All right. So the next grouping of problems really, like, I mean, you can do most of this. Most of this is meant to be done in the calculator, but there's like a little setup as well. The first thing here is to remember how to calculate a z-score. Z is x minus mu over sigma divided by the square root of n. Have you seen that before?
Yeah.
Okay. So in this problem though, because we're going from 30 less than or equal to x less than or equal to 43,
Mhm.
we have to actually calculate two z's, z1 and z2. So z1 is 30 minus 31, that's the mu, over 20. And because it doesn't tell us, and we don't know otherwise, n is 1. N is typically 1 unless they tell you somewhere that it's not, just to keep it
Okay.
simple. Now, it's really easy in your calculator to not do this calculation correctly, so make sure you put parentheses
Yeah.
there and there. We do need this value rounded to 2 decimal places. So if you don't mind calculating that, be good practice for the real.
I got
deal.
negative 0.05.
All right, you're much faster than me on figuring this out. Plus, yeah, I agree. All right, now we got to do the same thing for Z2. Z2 is 43 minus 31, 20 divided by the square root of 1. So do the same thing there for that one.
And then I got 0.6.
Yes. So the reason we're transforming this is instead of looking at it from the x perspective, you're looking at it from the z perspective. Minus 0.05 less than or equal to z less than or equal to 0.6, like that. So in terms of the normal distribution, what that means is 0 is right in the center. Minus 0.05 we'll just say roughly is there, not to scale, and 0.6 we'll say is there. You're finding the area in between.
Yes.
Okay. To do this on the calculator, you use what's called normal CDF. And that's, let me figure out where that is first. Okay, so that's under second distribution, which is above the vars. Clean that up there. Second DISTR, it's above the vars.
Okay.
And then you're choosing number 2, which is normal CDF. And then what it requires is a lower, an upper, a mean, and a standard deviation.
Okay.
So in your problem, the lower is minus 0.05, the upper is 0.6, and the mean is 0 and the standard deviation of 1. So for a z, the mu is always 0 and the standard deviation is always 1. Your TI-84 might just have a place where it says lower, upper, mu, and sigma that you just enter these, and then it has a paste button.
Yeah.
Mine
Yeah.
doesn't, so I have to kind of to do it the old way.
Yeah, I put it through and it came out with the right answer.
Oh, good.
So
Excellent.
you don't have to
Excellent.
do it.
Excellent. Okay. Now, a couple things here. If you don't know the lower, it's minus 10 to the 99. If you don't know the upper, it's 10 to the 99. We might see that in another problem coming up here. Okay. 32 is like 31, except it's already got the z value, so you just go right to the calculator for that.
Okay, we can skip that one.
Sure.
Um,
What's next?
Can we go down to the number 37? The
Yes.
last section.
So this is more integration, which I'm sure is Not super exciting. All right. The way I read this last part in italics is that they just want you to set it up and then put it in your calculator.
Yeah.
Which is good news that because the setup isn't hard. We've already done one in the calculator, so you know how to do this.
Yeah.
Okay, so the expected, there's supposed to be an F there. You can let the instructor know they made a mistake. Expected value of X is the integral F of X times X dx from A to B. So in your problem, your A is 0, your B is 1. Your F of X is right there, 3x squared. So it's 3x squared times X from 0 to 1 dx. So you're going to use that math FN int, math 9, and see if you can calculate that for us, please. You don't have to multiply the x squared times the x. I believe it'll just do it for you.
Okay.
If not, we'll talk about.
I got 0.75.
Yes. Now, if you needed to convert that to a fraction, you can hit math, enter,
Yes.
and it'll convert that to a fraction if it can. So that's part one. To find the variance, we did this earlier. You actually need something in between called the expected value of x squared.
Yeah.
Which is the same. It looks really similar to what we just did, except instead of x, it's x squared. So for you, this is the integral 0 to 1, 3x squared times x squared dx. So again, go ahead and calculate that for us, please. You may find it's useful to use what's called second entry, which is above the A and S button. And what that does is it recalls the previous line. Maybe you have copy and paste on yours, I'm not sure.
Yeah.
And then you can just edit it if you want. But go ahead and work that out for us, please, and let me know what you come up with.
How do you get to the integral in the calculator again?
Math FN int or math 9.
Yeah, I just I got 0.6.
Yes, 3/5, 0.6, perfect. Okay, now from earlier, you probably remember me writing the variance of x is the expected value of x squared minus the expected value of x, but then you have to square it.
Yeah.
So the expected value of x squared was 3/5 minus 3/4 squared. The variance has to be positive. So if you ever get a negative number, you either miscalculated something in between or made a mistake here.
Okay.
So that's the variance. We do need to get that before we can find the standard deviation. Get to my calculator. So I got 3/80.
Okay. Yeah, I got the same thing.
Okay, first, perfect. Now the standard deviation of x is the square root of that number. And that does not work out nicely. It's usually get a decimal. It might have even said to round to 4 decimal places. So actually probably should have used decimal notation for all the others.
That's okay.
So that's 0.1936.
That makes so much more sense than the first time.
Great, great. I would definitely recommend redoing the calculations.
Yeah,
You know, the most students just forget where to go on the calculator, and that's tough. All
yeah.
right. Time for maybe a quick question. I don't know what else is on your list here.
Which one of the last three do you think we'd have time for? Do you think we have time for any of those?
Yeah, we can. 39 is pretty short.
Okay.
38 requires a lot of explanation,
Yeah.
but uniform distribution, these are real nice. Again, like I said, if you can really go to Wikipedia uniform distribution, you get a lot of the stuff that you're probably looking for.
Mhm.
So the average of a uniform distribution is just the average. So the X bar, the expected value of X, whatever you want to call it, it's A plus B divided by 2,
Okay.
10,000 plus 60,000 divided by 2, right in the middle there, which is 35,000. All right. So you said your exam's next week?
Yeah.
Well, I'll definitely have some more availability if you need to schedule anything. If not, I wish you well on that.